All right, here's our problem. We have convert farads to millifarads by, and we have these three options of what we can do to convert. So with this problem, what we have is a farad. We haven't just talked about it yet, but what a farad is a unit of electrical capacitance. It's the ability of a body to store an electrical charge. So on a capacitor, you're going to have two plates separated by a dielectric material. And on the capacitor, basically what it is kind of like a little battery. It's going to store electrons on one plate and the absence of electrons on the other plate. And it's going to create a charge in between the plates here. And that electrical charge that's held in the plates, the unit of measure of that charge is the farad. So it's a little bit abstract, but at the end of the day, that is what it is. The equation for a farad or capacitance. So capacitance is equal to Q divided by E. So Q is the charge. What we're talking about when we're talking about a charge, we're talking about an amount of electrons. So we know that every atom has electrons. Excuse me. So we have the nucleus made up of protons and neutrons, and around the atom is electrons, right? That's the basic old school model, but how electricity flows is these electrons flow from one atom to the next down a wire, usually. So that's what we're talking about when we're saying charge. We're saying it's in coulombs, but what it is an amount of electrons. So it is actually going to be 6.28 times 10 to the 18 electrons is 1 coulomb. So what is 1 coulomb? It's 6.28. So we go and convert it. This is scientific notation. So we see that 18 is a very large number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right? All these zeros. I'm not going to go ahead and do all of them, but it's a whole bunch of electrons, right? More than we can count. So if I take one atom and I take its one electron from it and move it and put it in one spot and combine it with this many electrons, what I have is 1 coulomb. So 1 coulomb is just an amount of electrons. It's a very large number of electrons. So coulomb, the other thing that we want to make sure we remember is that a coulomb, the letter that represents coulomb is Q. So what is coulomb again? It's just a number of electrons. So it's this many electrons in one spot. If I put them all on that plate like we saw a second ago, here, if I had 1 coulomb of charge, 1 farad of charge, it would be amount of coulombs per the voltage that I apply to this capacitor. So it's a little abstract, but that's what it is. And also, we haven't really talked about it yet, but what is current? Current is like when we have current flowing in a wire. So we could have, here's a wire. If I have current 1 amp, so if I take this cross section of this wire and I take it over here and I just, right here. So what 1 amp is 1 coulomb per second. So what does that mean? That means that, remember that large amount of electrons, all the 0, 0, 0, 0, that many electrons moving through this cross section in 1 second is 1 amp. So 1 coulomb per 1 second is 1 amp. It's just an amount of electrons that flow through this wire. All right, perfect. So the problem now that we have here is it's asking us something different. We just kind of were explaining the coulomb, what it is. But, okay, so let's go ahead and look at these metric prefixes. So metric prefixes, what that does is it's a way to divide something up into smaller sections or to multiply it by to make it easier to be able to understand, I guess. Let's just take a look at an example. So right here I have 1 meter. So I think we've all heard of a kilo like a kilogram, right? Or if I'd said NBA 2K, that would mean 2,000, right? So K means multiply whatever you have by 1,000. Milli, what that one means is divide anything you have by 1,000. So let's go ahead and look at this. So we know that 10 to the third power is 10 times 10 times 10, right? Or which is 1,000. So what we may not know is that 10 to the negative third power is actually 1 divided by 10 times 10 times 10, or 1 divided by 1,000. So when I have a milli, what I'm doing is dividing by 1,000. And when I have a kilo, what I'm doing is multiplying by 1,000. So let's take our meter here. So if I have 1 kilometer, 1 kilometer, right? Kilometer. What I have is one of these meters, but times 1,000, right? I have 1,000 of them. 1,000 meters. So instead of writing all these zeros, I just write a K. So if you have 2K amount of dollars, that would mean you have $2,000, right? All right, so then a milli is the opposite. Instead of multiplying this 1 meter, what I'm going to do is divide. So I'm dividing by 1,000. So I'm taking this meter and I'm cutting it into 1,000 pieces. I mean, obviously this is not going to be 1,000 pieces, but what I'm doing is cutting it into a whole bunch of pieces, 1,000 of them. So if I have 1 millimeter, what I have is 1/1,000th of a meter, right? So that's the same for like grams, right? You could do the same thing for a gram. So we have a milligram, right? Everyone's heard of a milligram. We know that a cup of coffee has, I don't know, I think an average of 60, maybe, let's just make up a number. Let's say 1 cup of coffee has 200 milligrams of caffeine, right? So let's just take whatever this is. Here's our piece of caffeine. It's just some little mass of caffeine. Let's just say this is 1 gram of caffeine. So if I have 200 milligrams, what I have is 200 divided by 1,000 grams, or I'd have about roughly 20% of a gram. So if I have a gram here, what I do is I'd have 20% of this would be the amount of caffeine in that cup of coffee. All right, so hopefully that's understandable. But okay, so now we're going to go to the problem. So what our problem is stating is we have 1 farad. So it doesn't even matter. We don't need to know what a farad is. But basically what we have is 1 farad. It's some unit it's a unit of capacitance, right? So we have one of them, just like we had our 1 meter. But what we need to do is convert it to millifarads, right? So if I had 1 meter like we did before, if I had 1 meter, 0 to 1 meter, and I wanted to convert this 1 meter into millimeters, well, I would have to divide this into 1,000 pieces, right? But what I would really be doing is, if I have 1 meter, how many millimeters do I have? Well, I'd have 1,000 millimeters, because 1,000 millimeters is equal to 1 meter. If I had 2.2 meters, how many millimeters would I have? Well, I would have, for the first meter, I'd have 1,000 millimeters here. For the second meter, I'd have 1,000 millimeters here. And for this last portion, I'd have 0.2 meters, so I'd have 200 meters, right? So I'd have 2,200 millimeters. These two numbers are the exact same measure of unit. I mean, the exact same distance, right? So the whole idea is, why do I want to use meters and or millimeters and micrometers and kilo? Well, if I was going from city to city in a car, would you want to have the distances measured in meters? Would it be like, oh, from, one city to the next city is 230,000 meters? Or would you rather say 200 kilometers, right? So, and the same thing goes for something that's really small. If you're trying to measure the thickness of a fingernail, would you want to measure that in meters? You would say, oh, well, the thickness of a fingernail is 0.00001 meters, right? You'd want to express that in some smaller unit of measure that you could. So we'd use a millimeter or a micrometer or a picometer. So do know that you will have to memorize the pico, the micro, and the milli, kilo, mega. Giga's nice to know, tera. Again, you probably heard of a terabyte, right? What's a terabyte? Well, terabyte is 10 to the 12, which is a trillion bytes, right? So we have 10 to the 6, it's mega. So if I take my first, what I like to do is just go ahead and put 1 times 10 to the 6. So I can start here with my decimal, and I'll move over 6 spots. So I'd go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 10 to the 6 is a million, right? Well, 1 times 10 to the 9, which is a giga. So I do the same thing. Start here. Go 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is that? A giga is a billion, right? So then what is a tera? 10 to the 12 would just be the same thing. Take your 1 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that would be a trillion. So what is a terabyte of storage? That is 1 trillion bytes. And just like in the math section, you learned that a byte is 8 bits, right? Okay, so perfect. So on the opposite end of that, if I had a milli, so if I had 1 times 10 to the negative 3, like we learned before, we start with our 1. Decimal places on this place, on this side of the right side. If I go to the negative 3, 1, 2, 3. So that's going to be 0.001, which is equal to 1 over 1,000. Same for if I had a micro. Remember this micro, the symbol for micro is a mu. It's this little cursive looking U, and that's 10 to the 6. So if I take my 1, start with my decimal on the right side, I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I'd have 5 zeros, which would be dividing by a million. And the same for the pico. So the pico would be dividing by a trillion, right? So that's how you do this problem. I know it's kind of a long explanation, but here we go. We have the farad. So I'm converting 1 farad. So I have a whole, just like we had that whole meter. And I want to convert it to millifarads. So how do I do that? I multiply my farad by the 10 to the power of 3, or by 1,000.